As far as the billing of coals and fuel oils is concerned, so coal cannot be metered as in the case of the gas, because in the gas we can install the meters at the input, but here the coals, the case is different. Okay, so as far as coal bills are concerned, we are more concerned with the fuel delivery dates, the dates on which the fuel delivery is being conducted. Okay, and the rates which are applicable on that particular date. Okay, so whatever rates which are applicable on that date, so that will be taken into the consideration. And what else is to be taken into consideration is the combustion efficiency of the coal. Okay, so if the coal, when we are talking of the coal efficiency and or the combustion efficiency, we mean that if we are using good quality fuel, good quality coal, then it will have the good combustion. And as the quality goes down, our efficiency, combustion efficiency also goes. For example, if we are using the good quality coals like anthracite and bituminous, it will have the good combustion efficiency. And if we are using inferior quality, for example, peat, lignite, etc., so it will have the less combustion efficiency. So similarly, it will be charged. Okay, and also there are many factors also. uh, Ash content is also one of the problem in Indian coals, although the coals which are available in the Chinese coal is of better quality, but the quantity is large in our country. We are having the coal which is sufficient for us for nearly 125 years. Okay, so we are having the good quantity of coals still available, but the problem is the environmental issues. So now if we talk of the fuel oil, okay, so broadly when we are talking of these fuel oils, we are talking of the petrol and the diesels. Okay, so this can also be metered if the oil storage tank is having a meter. Okay, for example, if we are having any storage tank in our industry, or any, if any institute, if some institute is having say around 100 vehicles, 100 fleet of buses, so some storage tank is provided in house, so that can be metered. Other similar to our petrol pumps, because one tank, one full tank of the petrol or diesel, it is having the capacity of 12,000 liters or 12 kiloliters. Okay, again the quality is a issue here also, because the combustion efficiency of the petrol and diesel, or you can say petroleum products, is dependent upon the octane number of the fuel. Okay, so that is to be taken into consideration while oil bills are concerned. Next is the graphical analysis of the historical energy use. So uh, when we are talking of the graphical analysis, so one time axis is there and other is the fuel or energy intensity, or you can say electricity intensity or fuel intensity. You can say uh, the number of units or energy units which are being generated during the that set period because of the combustion of that fuel. That can be coal, that can be oil. And similarly, x-axis can be, it can be hourly basis, daily basis, monthly basis, annual basis, and so on. Okay, so uh, if the industry is such that it is using more coal, for example in the cement industries, these cement industries is also dependent upon the weather, because if there are cold conditions, then the combustion requires more time and more coal. So depending upon these weather changes, the output is also affected. The output of the cement industry is measured in MTPA, million tons per annum. Okay, so broadly we are focused on the energy intensity, which can be defined or formulated as given in the screen. So this is the energy intensity. It can be measured in kilowatt hour per ton, or kilowatt hour per kg, or gigajoules per ton. Okay, so main focus is that the first unit should be the unit of the energy. kilowatt hour is the one electricity unit, and electricity unit which means electrical energy. Okay, and similarly it can be 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules, which you must have studied in the class 9th, 10th, etc. And denominator is the weight. It can be the it is the production which is being done due to the consumption of those electrical energy, or in broad category you can say the energy. So that is the tonnage which is being used, produced. Okay, so uh, this is the energy intensity, and that it can be further classified in electricity intensity, which is the kilowatt hour, as I have just mentioned you that the electrical energy is measured in kilowatt hour. So next is the again fuel intensity. So this can be this fuel which can be used in gigajoules when higher, and the giga is the 10 to the power 9. Okay, so when higher level of energy consumption is considered, so that is the case here. This again fuel can be oil, coal, etc. So this is the typical example of the fuel intensity in which the x-axis is the time axis. It is given in the monthly manner. Okay, for any textile spinning plant. Okay, so this is the bar. Earlier was the bar diagram, or you can say it can also be represented in the histogram fashion. And now this is the pie chart. So what is the difference between the pie chart and the bar chart? In the bar chart, the higher it is the rectangular representation. So higher is the rectangular bar, higher is the y-axis or the energy consumption. Okay, that can be visualized. But in case of the pie diagram, the different components are represented in the percentages. Can be simply drawn. First of all, in a circle there are 360 degrees, and percentage is 100%. So 100 percentage is equal to 360 degrees. So 1% is equal to 3.6 degree. Okay, so if there are say three components as given in the figure, so based on the percentage, for example this 60% is given, so this 60% is multiplied by 3.6, we will get some angle, and that angle can be drawn using by measuring the angle using the d, you know, and different color representation is done here, and that is also classified, or it is to be mentioned in the block as given here. Okay, but if it is not given, and also if different colors are not available, you can also use different shades. So this is unit chapter is title is inventory and production patterns. So first of all, when we are talking of the inventory in the physical terms, we means that what is in the stores. Okay, but when we are talking of the inventory, we can have those storage physical hardwares or instruments or machinery, but main concern we are here with the data. Okay, that data is based on the previously collected data and also the ready or the current data, based on which the energy consumption is calculated. So it is broadly the liquid and the gas flows, the fluids. Okay, so these can be measured using the pressure, pipe size, pipe area, etc. Electrical measurements of the machinery, nameplate rating is given, so that can be verified for voltage, current, and power factor, etc. Temperature of the solid and the liquid surfaces. Okay, because if, for example, if we are talking of the boiler, if it is already at elevated temperature, it will boil the water earlier. Okay, and next is the pressure of the fluids in the pipes, furnaces, and vessels. What is the pressure? Because if we know the pressure, then based on those pressure and the time for which it is being open, we can calculate the fluids, and these fluids include both liquid and gas. Exhaust gas emission, CO2, CO, carbon monoxide, oxide, smoke, whether it is being emitted simply or by after tapping the its heat using condensation, etc. What is the humidity level of the industry? What is the luminance level? Whether the industry is illuminated well enough or not, whether the natural light is in or not, what is the artificial means which we are using for it, that all are to be considered. Okay, so broadly we can say that we are concerned with the electrical load inventory and the thermal energy use inventory. Okay, we are concerned with these two things. Okay, so when we talk of the electrical load inventory, we means how, where the electricity is used. Two important questions are to be answered. First is the where the electricity is to be used. Okay, second is how fast it is to be used. What does this signify? First of all, where electricity is used, which means that what are the loads. It can be the illumination loads, light, tube light, CFL, LEDs, etc. And second, it could be the motors, generators, some pressure systems, piping systems, etc. Okay, so how fast, we mean that if the rating of that machine or motor is more, then it will consume the electricity fast. Okay, so that is why how fast is important. Okay, and also how fast, which means that it is dependent upon the time, for which period, for how many hours it is being operated. So these two main factors are considered, and elaboration is also given in the section 5, which is in next unit or next topics that will be discussed later. Next is the thermal energy use inventory. So when we talk of the thermal energy use inventory, uh, we broadly consider the heat flow. Okay, or heat flow, and it can be, the heat flow is using three methods: conduction, convection, and radiation, which you have studied in the lower classes as well. So it also consider the refrigeration. Okay, or you can say that the temperature control systems are being considered, because in some of the countries or the systems we require more temperature than the normal temperature or the outside temperature, and in some countries we require less temperature, and refrigeration or the deep refrigeration is also the part which is, and that temperature is again maintained with the help of the electricity or the cooling devices. So this table is the checklist of the thermal energy outflows. So first of all is the conduction, and that conduction can be through the wall or the windows, and it depends upon the building structure. Air flow sensible. This is the general exhaust system which we have in our industries or in our kitchen or washrooms, etc. So this is the makeup air system and combustion air intake. Next is the airflow latent. This is the exhaust system that is used for drying purpose, dryers in use. So this is industries or equipments which are associated with it are the laundry system, pool ventilation, process drying, equipment exhaust. Okay. Next is the hot or the cold fluid. These are the fluids which are to be flown through the pipe system. It can be the domestic water, hot water system, or the process hot water, process cooling water as the condition demands, water cooled air compressor, etc. Pipe heat loss, when we are flowing any fluid, whether water or gas, then the steam pipelines, it may have some losses. That losses are also to be considered while calculating the thermal energy outflows. Same is the case for tank heat losses. For example, if we are having some hot fluid tank, which can be further used for boiling or steam generation for thermal power plants, etc. So when it is used for boiling or steam production, its temperature may be different, but during the passage of time and based on the Newton's law of cooling, its temperature will change. Secondly, the tank walls, so that are based on the isothermal process, whether those tank walls are isothermal or not, or which material it is having. So that all are responsible for the loss of heat, if any. Similarly, refrigeration system output heat. So when we are using cold storage, cold freezers, for example, the industries of the flower industries demand those things, or the deep freezers are also used for ice cream industries, and you can say seafood, freezed seafoods, for example, freezed fishes, crabs. Those who are non-vegetarians may be well aware of those things if they are going for purchase themselves. Next is the steam leaks and vents. Again, if the steam pipes are not well insulated, or if they are having some vents, leaks, then the more thermal energy is required for the required for the desired requirement of the industry or boiling. Okay, so how these energy outflows or inflows are calculated? These are broadly dependent upon the pipe area and the pressure flow and the times which for which these flows are responsible. If the pipe area is more, then more fluid will flow. Similarly for pressure also, whether those steam or hot water is pressurized to flow or not. As in the case of the thermal power plants, we get high pressure or high pressure steam or low pressure steam that is being propelled to the generators. Okay, so depending upon those. Next is the energy balance. So these energy balance are well analyzed using the Sankey diagram. So what is the Sankey diagram? So this Sankey diagram represent the energy losses, outflows, or energy gains or inflows. Okay, the energy, thermal energy, it can be steam energy, which is being pumped into the system. Okay, and energy losses, it can be due to leaking and outflows. Okay, so this can be represented in a different diagrams, inflows and outflows, or it can be depicted in the same diagram as well. Okay, so what are the necessities of the while drawing the Sankey diagram is that shape of the diagram is not of much consideration, but the width of the inflow and the outflow are important. Okay, here we have the diagram which shows the different input and output, or you can say inflows and the outflows for a cement production plant. So consider the first diagram of heat outlay, left diagram. So the thinnest width is 24 kilocalories. Okay, and it is used for clay deacidification. Next is the 337 kilocalories. So that is to be specified. Okay, that is to be nominated, described earlier, that what scale you are taking, that is more important. For example, if you are taking these 24 kilocalories at as 1 mm, then if we are drawing any other, you say 120 kilocalories, if we are scaling 24 kilocalories at 1 mm as 1 mm, then 120 kilocalories will be 5 mm. So those dimensions are important. Okay, so here in Sankey diagram we cannot draw the width of the inlays or outlays or input or output, inflows, outflows in a random manner. We cannot do that. Okay, so that is to be specified for both the diagrams. And also the Sankey diagrams are more descriptive when both the inflows and outflows are drawn in a same diagram. Okay, for example, you can say that left portion is for the inflows and left right is for the outflows. Okay, so here again the absolute values as given here can be there, or it can also be based on the percentage. For example, if this 24 kilocalories is given as 2% and another other heating up to 1900 degrees is given as a 8% or 20% or 24%, so that width can also be classified in this manner, percentage manner or absolute value manners. And again, the scale definition for the inflows and outflows can be similar or they can be dissimilar. Okay, although it is recommended that it should be similar.